Hi guys, for our final lesson in chapter 1, we are going to talk about solving quadratic systems of equations. So we touched on this a little bit at the beginning of the chapter, and we talked about what would it look like if a parabola and a line met up. And so we know that potentially there could be more than one spot where they meet up, depending where on the curve of that parabola that line touches. So it says solve the following systems of equations algebraically. So in order to do this, the first thing I would look at is trying to get a variable isolated to plug in and use substitution here. And it looks like we already have our x value isolated. Our x value happens to be equal to negative y minus 1. So I'm going to plug that in to that x value right there. So I have negative y minus 1, that whole quantity gets squared, minus 2y minus 10 is equal to 0. So then when I square this is like negative y minus 1 times negative y minus 1, we have to FOIL. So negative y times negative y is y squared, the negative times the negative cancels. We have negative y times negative 1, so that's a positive 1y. Negative 1 times negative y is also a positive 1y. And negative 1 times negative 1 is a positive 1. Minus 2y minus 10 is equal to 0. So then I have y squared plus 2y. 1 minus 10 gives me a minus 9, and then I have minus 2y equals 0. So my plus 2y and my minus 2y cancel each other out. So then I have y squared minus 9 is equal to 0. So from there, I can get, if I factor this, I get y plus 3 and y minus 3 equals 0. So y equals negative 3 and y equals positive 3. Then if I have two y values, I know that I'm also going to have two x values to go along with that. So I'm going to use this x equals the opposite of y minus 1 and plug in for y equals negative 3 and y equals positive 3. So x equals the opposite of negative 3 is 3 minus 1, so x equals 2. So this one is going to be 2 negative 3. And then x equals the opposite of positive 3 is negative 3 minus 1. So x equals negative 4. So our answer here is negative 4, 3. So there's our two solutions to that system of equations. All right, let's try another of these examples. So once again, we have something solved for y. So I'm going to use all of this and plug in to y right here. So 4x squared minus 3 times 12x minus 30 is equal to 18. So 4x squared minus 36x plus 90 is equal to 18. Okay, from there, I'm going to subtract 18 to set it equal to 0. So I get 4x squared minus 36x plus 90 minus 18 is 72 is equal to 0. I can see that all of those will divide by 4. So I get x squared minus 9x plus 18 is equal to 0. And then I need two numbers that multiply to 18 and add to a negative 9. So multiply to 18 and add to a negative 9. That would be negative 6 and negative 3. So I have 4 and I have x minus 6. X minus 3 is equal to 0. So x equals 6. X equals 3. this 4 out here, you're setting each piece equal to 0, so it really comes off as 4 equals 0, which is not true, so it's just not used. So then if we have x equals 6 and x equals 3, we're going to use this y equals 12x minus 30, and I'm going to plug in each of those things. So I get y equals 12 times 6 minus 30, so I get 72 minus 30, which is 42. So I get 642 is an answer. And then I get y equals 12 times 3 minus 30. So that equals 36 minus 30. So I get 6 as an answer. So then I get 3, 6 as my other value. So 642 and 3, 6 are my two values there. All right, let's try another one. So I have x plus 3x equals negative 4y minus 2. And I have 2x plus y equals 1. So what I would do probably is take the second one and make that y equals negative 2x plus 1. And then I would plug that in for my y value here. So then we have x plus 3x equals negative 4 times negative 2x plus 1 minus 2. So then this really just is 4x over here. And then we get 8x minus 4 minus 2. I'm going to go ahead and subtract this 8x from both sides. So I get negative 4x equals negative 6. I'm going to divide by negative 4. So x equals 3 halves, or 1.5. From there, I need to plug it back in. So I get 2 times 3 halves, if I plug into that second equation, plus y is equal to 1. So 2 times 3 halves is just 3, plus y equals 1. So subtract 3 from both sides, and y equals negative 2. So my final answer here is 3 halves, negative 2. All right, with our last two examples, we're going to use systems of equations on a graphing calculator. So what you'll want to do for both of these is solve to get y by itself. And so I'll help you to get to there. I'm going to have you try to plug it into your graphing calculator, use your intersect feature, and find your answer or answers. And then we'll come back in class, and if you have questions, we can go over it. So to solve this one for y, I'm going to go ahead and have negative 7y is equal to negative x squared minus 3. So I moved everything over that wasn't a y, and I'm going to divide by negative 7. So that I get y equals, and really you can leave this, I'm going to take the negative out, but you can leave that like this as long as you remember in your calculator to plug in with the parentheses so that it knows to take that x squared plus 3 before you divide by 7. You can plug that right into y1. And then for this one, if I subtract 2x from both sides, I get negative 2x plus 3. And then I need to divide by negative 1. So I get y equals 2x minus 3. Again, that one's easy to plug in for y2. So go ahead and try that in your calculator. You should get 2, 1 and 12, 21 as your answers if you plug those in correctly and found the intersect of both correctly. So try those out. Don't just take my word for it. All right, on this one, go ahead and try to get y by itself on your own. I'm going to go through it here with you. So everything on this first one that is not y, I'm moving over. So I have 6y equals negative x plus 1. I'm going to divide by 6. So then I get y equals negative x plus 1 over 6. And again, you can just leave it like that to plug into your calculator. On this one, same thing. Negative 0.4y equals x minus 2.6. I'm going to divide by negative 0.4. Y equals, and you can just leave this as x minus 2.6 over negative 0.4. If you want to take that negative out of there, you can. But both of those you'll plug in. Make sure to include those parentheses as you're typing them in your calculator. This one doesn't give you a nice answer, but it is 2 lines, so they meet up at 1 point, and I get 2.71 as my x value and negative 0.29 as my y value when I plug that in. So again, come see me if you're not getting those. We can talk about it in class as well. Have a great day.